everyone, myself Pratik. Today I'll be presenting about my project, which is Smart Video Rack. And before you get bored or zoned out after hearing RAG for like 100 times in a demo, let me tell you this is going to be different because we won't be dealing with PDFs or any text documents. We will be dealing with video, which I would personally like to call as final boss of multimodal data. And in this we will talk about how traditional RAG work, what broke, what was my idea behind it, and we will talk about cost, and I will also present you my entire demo as well. So let's first understand how traditional video rack work. So if you remove audio from any video, what basically are video? Videos are basically collection of images placed in a proper sequence, right? So traditional video rack perform very simple technique, which was uniform frame extraction after every n second. For example, if you have 10 minutes video, and you will be extracting after every 5 seconds. After every 5 seconds, you will extract one frame, then at 10, then 15, and so on. So for a 10-minute video, that's 600 seconds, and if you consider one frame per second, that's 600 frames. And if you are extracting it after every 5 seconds, that's 120 frames. So you can imagine, like if you scale that video for 1 hour or 2 hours video, your cost is going to blow up. The second main issue with the traditional video rack was there will be so many duplicates because the screen doesn't change after every 5 seconds, right? Screen may have the same visuals for over like 1 or 2 minutes, so there will be too many duplicates. So then the traditional rack become a bit smarter. So there are techniques called as pixel diff and perceptual hashing, which basically compares two frames, and when you compare these two frames, we are able to deduplicate those frames. But there's still one issue. As you can see these two images, like if you look at its layout and its color, these two frames look similar. The pixel diff and the perceptual hash technique which I told, they won't be able to tell difference between these two frames. But these two frames carries different information. If you see text on those, these two frames carries different information. So if we deduplicate this, we will lose information in this. So that's how traditional video rack failed. And the one thing that traditional video rack does is, how did the frame change from the past frame? But I think the right question would be, did any information change from the past frames? So before showing you my solution, let me first convince you that why video is the toughest data to handle. Like you must have all worked with RAG workflows and build your own PDF RAG, right? So during that you work with only one kind of modality, which is text. You deal with textual information. But in video, we have to deal with three different types of modality. First is text, second is audio, and third is visuals. So you must be questioning, why text? Why do we need text? So consider a video, a screen recording, or someone explaining a code or a slideshow, and which doesn't have any audio. So in that case, the text become our main key information, right? So we have to extract text as well. Second is the audio. Like I don't need to explain why audios are important in video, because that's the whole explanation lies. And third is visuals, which basically means what exactly is happening on screen. And the main thing is, all these three modalities are not independent, they are all dependent. Like imagine a tutor explaining, as you can see on this screen. But if you just index the transcript, you won't be able to understand what exactly the speaker is pointing towards, or what exactly is the context of that entire scene, right? So we have to fuse all these three modalities together. We have to make these three modalities work together. So that's why I think videos are toughest to handle. And we have all known that even if we are dealing with one single modality, which is text, we face so many problems. Now imagine tripling it and fusing it together. So dealing with videos was one of the hardest things. So you must have seen this formula everywhere. Like during our past OAISYS conference, this was present on our, even on the stickers as well, there's this formula. So this is basically attention formula, which was introduced in Attention Is All You Need paper, the paper which actually revolutionized AI, like which gave rise to transformers and everything. And one day I was actually revising this paper, and the beautiful underlying concept is very simple, that not all tokens deserve equal attention, right? So that's when it struck me that that's the same case in video. Like we don't need all the frames to process together. Like we don't need all frames to for getting the right information from the video. We need certain frames. Like that's when I had a question, like what if we could build a system that would pay attention to videos in similar way the transformer pays attention to tokens. So only the frame that matters or that deserves attention should be taken. Now, how to identify these frames? And I like to call them as keyframes, the frames that carries unique information from video. So how do we identify these keyframes? So for this, I have implemented two layer system. First is text layer and second is visual layer. So in text layer, we will extract text from the frames. So how will we do it? I basically sample frame at every 2 to 8 seconds. So after then I pass it through 3 different filters. So these filters are local filters. So first is PIL imaging, which is Python imaging library, and I conduct a complete edge detection on this. So it basically tells how many horizontal or vertical lines are there and tells its density on the image. It basically scores whether this image has text information or not. So that's PIL imaging. And pixel diff and perceptual etching are basically to remove duplicates. So it compares it with the past frame and just remove duplicates from it. Then we pass it to a GPT-4o mini for textual extraction, where we perform simple OCR task and we extract text from frame. Then the second layer is the visual layer. It kicks in when there is no text present on screen, there are only visuals. So for this I simply have implemented pixel diff, which basically tells what is the difference between two frames. So if the frame is different, say more than 30% or 40% from the previous frame, we will consider it as a new keyframe. So basically my definition for keyframe becomes any frame that carries new textual information or any frame that carries new visual information, that becomes my keyframe. And the result was, when I indexed a 10-minute video, if you consider similarly, like if you consider 1 frame per second, that's like 600 frames. But when I implemented this, the frames that were actually extracted reduced to 38 to 40. So basically we will be removing 90% of the redundant frames by still keeping all the information that we need. So that's how I have performed keyframe extraction. So handling three modalities. I already told how I handle text in the layer 1. For audio, I am actually doing a simple check, which is whether the video has inbuilt transcript or not. Like many YouTube videos have their own inbuilt transcripts. If not, I have used Whisper model. Whisper is basically speech to text model. So I have used that for generating transcript for it. And third is the visual. For visual, I am using GPT-4o model, which gives a proper visual analysis of any frame that we provide. So that's how I have handled 3 modalities in my system. Yeah, so this is my complete pipeline of my project, and okay, it may seem scary to look at, but it's very simple. So first we will upload any video. So you can paste in any YouTube link or you can upload from your local data. Then we do a transcription detection, which basically detects whether it has pre-built transcript or whether we need to call Whisper model for that. Then there are 2 parallel processes that happen. One is the keyframe extraction, the one which I explained, the 2-layer system. So here we will do visual analysis and text scan. But along with that, I am also doing topic segmentation. So topic segmentation basically works on the transcription which we take. So it basically provides at what timestamp what topics were discussed, what was the topic that was discussed during this timestamp or during this time frame, that we get from topic segmentation layer. And then is video identity. So video identity basically tells you what type of video it is. Is it a conference video? Is it a tutorial video? Or is it a normal video, like that? Then it gets divided into, like, it takes key moments from the video, which basically defines what were the key moments in entire video. So we take all this information, and here's the fusion actually take place, which is the hierarchical chunking and multimodal fusion. I basically convert this information into 3 different types of chunks. So first chunks I would like to talk about is video overview chunk. So every video gets one of this chunk, which is video overview chunk, which provides the basic information about what the video is about. So every video will get one overview chunk. Then second is the summary chunks. This summary chunk will work on the topic segmentation. So whichever topics are covered in the video, so each topic will get one chunk for it. And third is a detail chunk. So in detail chunk, I have divided it into timestamp of 30 seconds. So whatever has happened in that 30-second, basically all the text extracted, the transcription and the visual changes all get embedded in these detail chunks. And after that, I have used text text embedding 3 large model for generating embedding, and I have stored it into vector database. Then whenever an user asks a query, I basically do re-ranking and retrieve the correct chunks for answer generation. So let me take you to demo as well. Yeah, so this is my video rack. As you can see, like I have indexed around 15 videos in my video library. Here you can see how it was transcribed, like whisper with transcript, or if it has no audio, then no audio. And on the top left corner, you can see how many keyframes that video has. Okay, so I will ask one question, like, so it will find the exact moment when that topic was discussed from the entire video library.
Use fine tuning wherein you want your model to be trained on a new pattern.
Yeah. So this was actually discussed by Piyush sir in last OAISYS conference, like when to use fine tuning. And along with that, it also provides also relevant video. So it basically ranks and provides which other videos are also relatable for this query. I can ask one another question, like,
Low rank adaptation or more also efficient.
so it basically takes you there. Now I have one video of Elris. So this is one of the rack platform we have, where I have indexed this video and it doesn't have any audio in it. So we'll just refresh this screen and I will ask. So yeah, it took at the right moment when I was building a knowledge base in Ilris. And here, as you can see in chat, it also provide the exact step we have to took to create knowledge base in Ilris, like Ilris access Ilris AI setup, then configure data source, select content and enter basic information, then choose content processing method, simple or contextual. So it didn't have any audio, no one was explaining this video, but it built this information just through visuals, just by extracting text from the video. I will upload one video and I will show you how it process. Simple, so you can add your YouTube URL over here and just download and process. It will take some time, so we can if anyone has any question, anyone wants to discuss, we can start now. Yeah, we can extract like this information from GPT-4o, so we can add that into our system prompts that extract what color and everything is wearing. Yeah,
It's very good tool. I mean, if I want to search on, if I have a library of like tutorial and I want to go to a specific, this will be very useful.
yes, yeah,
I was just wondering for random questions.
yes. And we can index like up to 1 hour of videos in this, so you can index podcast or anything and just jump to the point where that specific topic was discussed. So right now it's extracting keyframes from one of this video. I've also built certain use cases which can be used for marketing and marketing people as well, so I will showcase that as well. Yes, so all of these three get fused in hierarchical chunking. So we are maintaining 3 different types of chunks in this. So one is video overview. So in that for every video we get one chunk which contains the entire information about the video. Then second is the summary chunk, which for every topic we generate a separate chunk. So like if a video contains like 10 topics, that video will get 10 different chunks for it. So it will be easy for us to retrieve. And as we get the timestamp from transcription and video, so we are able to jump to the exact moment when the topic was discussed because of the timestamp here. So as you can see, the dark web, tier network, then surface web, deep web, every single topic gets extracted during processing of video. So we can just refresh and ask. Mhm.
You may also want to double up and use a virtual private network that carries your traffic end to end.
So yeah,
And
it
with
jumps
that,
the exact point with providing a proper chat response for that. You can upload any videos for that, but the cost will increase. That's it. But you can upload any 2 hour video or something like that. For security camera, that use case become thoda different than this. Yeah, it comes in computer vision part. But the color extraction and that can also be done in this. Yeah. And this is not only limited to tutorials or any such video. You can ask like any podcast. I have indexed one podcast as well.
I also had this question about computer vision. So computer vision के case में, I think then वो keyframe वाला idea we won't be able to apply because it there probably we need to process the whole
in the
bit.
image on the right,
Yes.
red equals the areas of
Yeah.
high activity.
So it basically just jumped to the point when that doctor was explaining ADHD. So this video rack can be worked on many different types of videos. It's not limited only to tutorials. So for non-tech people who are working in marketing, so I have built one use case. So first I have to select one video. Yeah, this is my session. So from the last OAISYS conference. And here you can select your target audience, like say suppose AI engineers are my target audience, and I will just select which social platform you want to post videos from this. I will just select find LinkedIn worthy clips from this video, like this. So it will analyze my video and it will generate or it will provide proper caption, titles, everything that can be posted on LinkedIn, and the 30-second video clip that would directly go as on LinkedIn.
This query which you sent is
Yeah, I selected LinkedIn above, so there's an option of different social medias. Huh?
the question like when you ask key generate LinkedIn worthy clips from the video. It's not coming from the transcript, but it's actually
From from transcript and all the other things as well, like from the visuals and the text, all three. So like it created like current track systems are static here. Why that's a problem? So this was covered in my adaptive rack, and it also provided me a timestamp when that was discussed. Like just
The RAG adapt I got I think like if you consider the RAG right now, whenever user asks a query, it does the same thing everything. It will
so so this is how I extract, and it also provides what should be the caption for it. So it becomes more easy for non-tech marketing people to deal with such technical videos. So coming back to this, yeah. So these are the few edge cases which I faced while building this demo, while building this project. So one first was the OCR flicker detection. So when you are watching a YouTube video, there's always a subscribe button popping, like subscribe like that. So when I index my first video, it was about 5 minutes of video. It extracted every single second as a new keyframe because that subscribe now was kept on popping every single second. So I had to write a different function for it. Like if a text occurs like multiple times, we have to suppress it. So that was one. Then the perceptual hashing I already explained. It basically conducts proper deduplication on similar looking frames. And third is the memory management. So how I have managed this is, so imagine you are processing 1 hour video and you are processing every frames for text extraction, for visual analysis, and my Docker container is only about 4 GB, so it can't process every single frame in that limited space. So what I have how I have implemented it is I have performed wave based processing. So it first take about 20 frames first, then it processes on it, and then we clean up. We just delete those frames because once the information is extracted, we don't need those frame anymore. Then the OS reclaims its memory, and that's how in waves we actually have managed memory in this system. Now, yeah, how is it different from YouTube search? Like even if you go on YouTube, there's a button like ask summary and something like that. but that only works on transcription and the metadata which was provided by the YouTuber, like the timestamps and everything. It can't really answer questions which are visually present in their YouTube video, like can you explain me the function, or what is the use of this function, when did the user spoke about certain topic. That can't be extracted from YouTube search. So this is the cost comparison with traditional RAG. So I have took example of 10 minutes, and so if we take example of 10 minutes video, that will be like around 600 frames, and if we extract every single frame, so in traditional frame it will be about 600 frames, and my video RAG will extract about 30 to 40 frames from it. Then you can see the cost comparison about the traditional RAG is about $2.4, and for the smart video RAG is about 0.45. And if we scale this to for 50 videos, the traditional video RAG will jump up to $120, while mine will work in only $22. So yeah, and there will be no noise, there will be no duplicates value in my system. So if anyone has any question or any suggestion, it only works on English. So but it can be scaled for like multilingual as well, but for that we need to use a different model rather than Whisper, so which can transcribe it properly. So yeah, that's it. Thank you.